Some time ago, someone expressed an interest in seeing some sort of an automatic hip setup. Uh, in their case, they were expressing it in relation to the spine setup. Usually, I don't do an auto hip but directly related to the spine, just because, for one, the spine its movements are sort of, in my opinion, independent of the spine, so they really shouldn't be incorporated together. If anything, the hips and the root would basically be considered before the spine reacts to their movement. So I basically create a setup that shows a basic hip setup with a few tweaks. So in this case, I have a setup that has a manual control for the hip rotation in the X, the Y, and the Z axes, but it also has an automatic feature, which I also have a switch set up for to turn it on and off, which basically just responds to a change in the distance between the foot controls and the root. I could have done it based on distance, but that seemed a little bit arbitrary, especially when it comes to scaling. That I have to add another tier to it to account for scaling. So in this case, I just did it based upon an average of the change in placement of the foot and the root control. So in this case, I've already set it up for only the left side, not for the right side yet. So if I translate my root and my hip, notice there's actually no change. I mean, my root and my foot. There's no change in the rotation of the hip. Okay, because they were maintaining an equal distance apart. And notice nothing's happening for the right foot because I haven't actually set that up to respond to it yet. Okay, but no matter where it is, I can take the foot and move it, and now you can see the hip is actually responding to the change in displacement. And if I want to minimize how much it responds, I can pretty much just come into my offsets here and make the change. And so I'd go to the Y to counter that rotation if I wanted to. Okay. And of course, with the switch available, I can just turn it off so that only the manual control responds. So this setup is basically comprised of, you have the two control curves for the root and the foot. You have the plus minus average node, two multiply divide nodes, a second plus minus average node, and then of course the joint itself. The unit conversion nodes are automatically generated once you make the connection between the plus minus average node and the hip joint. Okay. In this case, though, we're going to actually just feed more into the plus minus average node. So this one actually shouldn't be left. It should be sort of just hip, because it's going to receive all input from the left and the right. Okay, so now for the right foot, if I want it to actually behave just like my left foot is, I need to start building. So first what I'm going to need is I'm going to need a couple more nodes, or I can reuse these, but just so we're clear, I'm going to select these two, I'm going to duplicate them. So I've got mdiv right for the y axis, and then mdiv right for the x-axis of the hip. Now if you want to simplify it, you could just use one node for each, and then just make sure you pay very careful attention to where you're actually feeding your attributes, so you can just save some real estate. But in this case, I'm going to keep it pretty clear and pretty straightforward. So we've got plus minus average node for the right side now. Okay, and so this is pretty much what we're gonna make connections from. So root, foot, plus minus average, two mdivs, another plus minus average node, and then the hip joint. So before you start making any connections to get things working, you want to check your hip joint and find out what its orientation is. Essentially find out which axis is controlling which type of movement. So in my case, the x-axis is controlling the twisting from left to right. The y-axis is going to control the hip rocking movement from left to right, and the z-axis looks like it controls sort of the hip thrust. So when I say the rocking, when I go to the y-axis, notice how it rocks from left to right. Okay, and if I go to the x, you can see it gets the twist. Okay, and so those are pretty much the only two we're going to automate. Usually when it comes to the z-axis, don't really need any sort of automation. That's not, I mean, essentially that axis comes in handy, but most often when you're doing the majority of your animation, it's going to be the y-axis and the x-axis, which would normally react to the displacement of the feet the most. Okay, so some of the first connections we're going to make are going to be from our controls. So I'm going to take my root, I'm going to make connections first to its plus minus average node. So when it comes to the controls, they have a slight different orientation. So if I want to, let's say, control the rotation on the hip relative to the rocking of the hip, that's going to be dependent on the y-axis, or the movement in the translate y for my root and my foot. So that when I lift my foot or lower it, or lower my center of gravity, the hip sort of reacts to try to compensate for the shift in weight. Okay? And so what we're going to do is we're going to load in our right foot, because it's not going to be, because the left is here, but the right is here. And we're going to need the sort of the root. The root has to feed into both, essentially. And so we're going to take our right foot, and we're going to feed its translate y, we'll do the y first, into input 3D. And usually what I do is I'm going to feed it into whichever axis it's supposed to impact. So in this case, it's going to influence the y-axis. I'm going to feed my translate y directly into y. Now, in the case of the foot, it's also going to be the y-axis. I mean, in the case of the root, it's also going to be the y-axis. It's actually going to change a little bit when it comes to moving the foot front to back. So we'll get that in a second. So translate y from our root, feeding into the plus minus average node, input. And in this case, they need to average, so we're going to feed it into not the same input, so it can't feed into input 0, because that's where we have the first one feeding in. Okay, so we need to feed into the next input down under the same attribute, but on a separate input. So if you actually expand, you can actually see we actually have input 3D, and the input 3D actually has 1, 2, 3 inputs under it. Now it has 3 inputs because as soon as I created, or as soon as I made a connection to the first input, it automatically generated a second input just in case I needed to use it. And then when I made a connection to the second, it made a third just in case. But as you can see, in both cases, the input 3dy on each one is receiving the connection. And that's because if you actually go to the node, if I double click on it, we can actually see that it's now paying attention to where our root is and its translate values versus the translate value on our foot. Okay? And so another thing, you're going to make sure you switch the operation from the default, which is sum, and switch it to subtract, because we want to basically discover the change in distance between the two. And so since both start at 0, once one moves, there's a change, and we can actually use that change to control our hip. We want to take that plus minus average node. Now it's actually receiving input from the translate y's, and we want to feed it out to the mdiv right hip for the y as well. And so we're going to feed its output 3D y to the input y on our multiply divide. And this is again just so that we can keep track of it easily. Okay? And so before we move on, I'm going to come back in and now do the translates for the z-axes, because on our controls, the z-axis is actually going to be relative to the displacement of the foot and the root, even though the rotation we want to control is going to be the x-axis. And so what we're going to do is I'm actually going to take that output and I'm going to feed it into my input x, because I want to control the x. And so taking the translate z and feeding it into the input 3D x of each one of the inputs. So again, whichever control you're feeding in first, feed it into your first input, which would be your input 0, input 3D x, and then the second one should feed into the input 1, input 3D x. Okay, so that it looks like this. Input 3D 0, input 3D x. So this is the x, this is the x. Remember, it's x, y, z. And so input 3D 0x, input 3D 1x. So once we have those connections made, we can come in and we can feed our output here as well. So output 3D x is going to feed into my mdiv input x. So now we have the y and the x. So once you have the connections made on your multiply divide nodes, you may want to go into each multiply divide node and set the input 2 of the corresponding attribute so that it's actually a higher value. Because we don't, essentially by default, when you look at a multiply divide node, what you're going to get is you're going to get input 2 is usually going to say 1. It's going to be 1 across the board. And the default operation is multiply, and that's what you want. You want multiply as your default operation. On input 2, though, you usually want to set a much higher value for the incoming input, the translate value, or the input average value, to multiply times so that it can actually output a higher degree of rotation for your hip joint. So in my case, I chose to use the value of about 15. In this case, it's a negative 15 on my right hip, because it's 15 on the left, because they're going to basically rotate in opposite directions. Okay? Because if you leave it set at 1, it's not going to rotate very much at all. So you definitely want to increase that secondary, that input 2 value, so it's actually a little higher. You want to make sure you do that for both the hip X and the hip Y values. And again, if you are using one node, since we are just using basically the X and the Y value, you can feed them both through one node just to save yourself some real estate. And hopefully to save yourself a little confusion as well. And now we just need to feed these into our plus minus average node for the hip. Now, the plus minus average node for the hip itself, that's feeding directly into the hip, that's the operation on that, it's set to sum. You want to set that to sum because we want it to basically add all values that come into it so that we can essentially average the behavior out nicely from left to right. So in the case of our mdiv y, we're going to say output y. It's going to feed into my plus minus average node. It's going to input 3D, and since we already have the manual input and the automated input coming into the first two, we're going to feed these last connections into the final input. So y goes to input 3dy, and then x goes to input 3D number 2, x. Okay, so now if we come back in and take a look, I'm going to move the foot down. Okay, when I move it up, it raises the hip. When I lower it, it brings it down. Okay, so now if I take my right foot control and I translate it forward, you'll notice that it's actually twisting the hip, but it's sort of twisting in the wrong direction. And that's actually an easy fix. You simply come to the the node that corresponds to it. In this case, it's going to be our mdiv right hip node. And notice that the input is multiplying the input 2x by 15. That's just an arbitrary number that I chose to essentially increase the input value that's being fed out of the multiply divide nodes so that it will react faster. But in this case, it actually needs to be the opposite value of what it is, so it needs to be negative. So it rotates our hip in the opposite direction of the direction that the left foot is trying to do. So if I actually brought the left foot forward, it would actually try to center the hip now. So if I brought the root down, as you can see, since both the left and the right are currently controlling it, it just averages and maintains a rotation of basically 0 for that hip. But if I extend the leg, now you actually see that the weight shifts so that more of the weight's being put on the right side. Okay? Now, the great thing about setting up this way, so it's actually doing it relative to the change in distance between the two controls, or shall I say the range of movement between the two controls, is that it's scalable. You don't have to multiply it times anything. As long as the controls themselves are part of the scaling setup, it should work fine. So this way you can easily move the feet and the root away from your master control and still have everything work properly. And as I said, it is scalable, so if I scale it down, you'll see that there's no change in the rotation of the hip. Everything still works perfectly. Okay, so if you take a quick look, I just pared things down a little bit for our multiply divide nodes that are controlling our rotation for the hip, and I pared them down just one for each, one for the left and one for the right, so that we have an mdiv left hip x and we also have an mdiv right hip x. And I just basically took the xy values and I fed them directly through the input 1x and input 1y of each node, just to save a little real estate, because now if you actually want to add an auto switch, we're actually going to need two nodes, one for the left and one for the right. Okay, so we'll take that spare node and use it for the switch instead. Okay, so we got that one, and I'll duplicate that one just to make one for the right to put aside for later use. Okay, but for now, let's focus on this one. So now I want to set up that auto switch for the left side first. So what we need to do is we need to actually take this switch, we need to drop it in between plus minus divide node that's feeding into the hip and the input from the left side of the hip. Okay, so we need to drop it right in here so that it can either divide the automation, basically either ignore the automation or allow it through. And it's going to be a simple setup. We're going to have the switches value feed in, and we're also going to have the values coming from the node feed in as well. So let's do that first. So I'm going to take my XY hip node, I'm going to feed its output X into the input X. I'm going to feed its output Y into the input Y. Okay? And then we need to actually take the switch that I made, and if you're going to make a switch, you can pretty much put it on any control curve you want. I put it on the hip because that's also where I put the attributes that are going to manually control the hip rotation. And to add an attribute, remember you select the object you want to add an attribute to, you go to the modify add attribute, and it'll bring up your add attribute window. You could also select the control curve, and from your channels box, if you press Control or Command and right click on your channels box, it'll actually bring up this little pop-up, and you can choose add attribute from there, and it'll also bring up the same window. Okay, so once you have that up, you can choose, you can start typing a name, a long name for it. So in this case, let's say auto hip, for example. And then under data type, you choose enum, and then you set the first value where it says green, you set that for off, because the first value is always equal to 0. Second value, you're going to set it to on. Second value is always equal to 1. And you can add additional values, but it goes up incrementally, so that this will be equal to 2, and the next one will be equal to 3, and so on and so forth. But basically all we need is 0 and 1, or off and on. And then you just say add, and it adds the attribute into whichever curve you have selected. And so you have now a little pull down of off and on. And now we need to connect that switch, which is on my root control, in so that it now influences the switch itself. Okay, so I come into where it says auto hip, that's the attribute I created. I find its output, and I need to feed that into the input 2 X and Y, because I want it to influence both of them when it activates. Okay? So now, no matter what value is being fed through there, if it's 0, it's not going to have any effect on the output. And so now I take the output from this node and I feed that in to take the place of the output from my X, Y node. So I take its output X, feed it into the input 3D, and remember I chose to use the third one is for the right side. The left side would actually went into the first zone on mine. So we're going to feed it into the input 3dx, and then output Y, feeding into the input 3D Y. Okay, make sure you're choosing the right zones when you're feeding this stuff in so you don't get confused. So for my left side, the automation should still be, it should be off. So if I move the leg, notice no automation on the hip. Doesn't rotate at all. However, if I come over to my root control and I switch to on, it should automatically switch on. So now I have the on-off switch. So if I come in now and I switch it to off, and then I come to the right leg, which doesn't have the automation disabled, notice the right side still influences it. So if you wanted to, you could set it up so you could have two separate switches if you wanted just the right side to respond. But usually, if you're going to have one side respond, you're going to have the other side respond as well. Either way, you can still have the manual inputs in there. And to set up the manual inputs up, it's actually pretty simple. You essentially are just going to connect those attributes directly in to the plus minus hip node that everything feeds into. And so you go to your root where those attributes live if you've created them using the add attribute, and you basically just want to go in and choose each one. Let's say the hip X, go to that last plus minus average node and go to the very last input and just start making connections, input 3dx, and hip Y to input 3dy, and so on and so forth. And so that then you have the option of using manual control or the automation.